Hello, my name is Mr. Asprey and this is Edexcel IGCSE Maths Predicted Paper 2HR. Now, disclaimer, no one knows exactly what will be in paper 2HR, only the examiners. This paper has been created by me after analysis of the previous IGCSE paper and other IGCSE papers. Use this practice paper on top of your revision. The best plan is to be comprehensive and revise all the topics. So I will point you in the direction of my video where I go over examples on every single topic. And I'll also point you to my video where I go over everything you need to memorize for the IGCSE. And then finally, I do have a playlist of exam questions by topic, which I have reordered specifically for paper 2HR. So check that out as well. Be comprehensive. Make sure you go into the exam knowing as much as you possibly can. And also, if you find this useful, please do subscribe, like, and share it with your friends. Let's do it. Question 1, write down all the values of n such that minus 2 is less than or equal to n, which is less than 3. So that means that n is in between these two numbers, so it could be minus 2, minus 1, 0, 1, 2, and it can't be 3 because it doesn't equal 3. On the number line, represent y less than or equal to 1. So draw a circle of 1. We want less than, so we go this way with an arrow. And because it could also equal 1, it means that we shade in this dot right here. Question 2, we're going to want to convert these into mixed numbers first. So I do 4 multiplied by 6, which gives me 24. And then I add 3, which gives me 27. So it's 27 over 4. Divided by, we do 7 times 2, which is 14, plus 4 is 18. So that's 18 over 7. It's a show that question, so I don't need to use the answer. I'm just going to refer back to that at the end. Now, when I'm dividing fractions, I will flip over the second one and turn it into a multiplication. I will then look to see are there any factors I can cancel. Well, yes, there are. There's a factor of 9 on the top and a factor of 9 on the bottom. So I divide through by 9 and I divide through by 9. I can now multiply the top and the top, which gives me 21, and the bottom gives me 8. Now, how many 8s fit into 21? That is 2, which makes 16, and then 5 left over. So 2 and 5/8 is my answer. I check to see if that's the same as they got. Yes, they do. Therefore, I know I've got the answer right. Question 3 looks like a pretty standard trigonometry question. We've got the angle 65 there, which means that this side is the opposite, and the side that is next to the angle is the adjacent, and the hypotenuse, which is opposite the right angle, is there. And I want to find the length of AB. So I want this length, and I know this length. So which is the trig function with O and H? That is sine. So I draw my triangle, sine of the angle is O over H. I'm trying to find O, so I cover O in my triangle, which tells me that the opposite is equal to, the 2 down the bottom means multiply them together. So sine of the angle multiplied by H. So in this case that is sine of 65 multiplied by 8.4, being sure to put that in brackets there. So I go to my calculator, and I press sine of 65, close brackets, multiplied by 8.4, and that gives me 7.61 to 3 significant figures. Yes, that is correct, 7.61. Great. Okay, question 4, we've got a question on percentages and we've got fractions involved as well. It says one day she makes 150 mugs and her total cost of the mugs is 1,140. 2/5 are small, so I'm just going to write that as a percentage, and 1/5 is 20%, so 2/5 is 40%. 32% of them are medium, and the rest are large. So how many are large? Well, 100% minus 40 minus 32 is 28, so 28% are large. And this is how much she sells them for, and she sells all 150 mugs. So, in terms of the small ones, that's how much she costs, and she sells 150 and of which of them she sells 40%. The medium, of the 150 she sells 32%, and of the large, of the 150 she sells 28%. Okay, so let's work out each of these values. So on my calculator I do £8.50 multiplied by 150 multiplied by 40%, which is the same as 40 over 100. So that's 510. That's how much money she makes out of those. The next one is £11.20 multiplied by 150 multiplied by 32%. So that is 537.6. And then the next one is 14.2 multiplied by 150 multiplied by 28%. Okay, and that is 596.4. Okay, great, I'll add them all up. So add the last answer to 537.6 plus 510, and that's how much money she makes. So the percentage profit is how much money she made, take away how much she cost, which is 1140, divided by how much she started with, or how much it cost, which was 1140. And then of course multiply that by 100 to get it as a percentage. Okay, so this gives her her profit, and then we divide that by how much it was out of, and then we times that by 100, and that is 44.2%. So it's the nearest whole number, that is 40%. 44%, sorry. Great. Okay, Yusuf sat 8 examinations. Here are the marks for 5 of them. And for his results, they had the mode was 80, the median was 74, and the range was 16. Okay, so let's just write these out again. And what we're going to try and do is, first off, there are 8 exams, which means that the middle 2 must average to make 74. Because that's the median, and because there are an even number of numbers, we won't have a standalone median, we'll have 2 in the middle. And also, because the mode is 80, that means there must be at least another 180 over here. So this would be the sort of 4 on the right. So if I were to squeeze in a 73 here, then that would give me the perfect median. So the 2 in the middle would average to make 74, which is what they need to do. So far I've added on 80, and I've also added in this 73. Now there's one more I need to add in, and I suspect that the range of marks is going to help us here. Because from 80 all the way back to the smallest one, there must be a gap of 16, so therefore this one must be 64, and I think that works. That has all 3 of our ones added in, and everything is satisfied. So the answers are 64, 73 and 80. Okay, next question is on lowest common multiple, and when a question like this is 2 marks, you can do the Venn diagram method, but sometimes it's just easier just to write out the times tables. So if I were to just add up the 36s, then I'm going to get to here, I'm going to get to here, and in fact I'm not. And if I do the 120s like this, the one after this would be a 2 and a 5 and a 2, and the one after this would be 360, and that 360 is going to be the lowest common multiple. So I know it's definitely a multiple of 36. I can keep going, obviously, if I just to prove it. 2, 8, 8, and then after that it would be 3, 2, 4, and then it'll be 360. So yeah, 360 is the lowest common multiple. Okay, we have here, next question. We've got A, we've got B, and we've got M and P are integers such that M is greater than 2, N is greater than 10, and P is greater than 1. Find the highest common factor of A and B, giving your answer as a product of prime factors. Okay, so the highest common factor is we find the numbers which occur in both, and it's always the lowest power that we use. So because M is greater than 2, then they don't share more 5s than just 2. So 2 5s is the maximum they share. So 2 to the 5 is going to be part of the highest common factor. And now it says n is greater than 10, and that means that n minus 5 is 5 or more. So again, the lowest number of 7s they share is 4. So it'll be 7 to the 4. And then here, p is greater than 1. So the lowest number of p's they share is just p to the 1. So that's how we would work out the highest common factor. If we were asked to work out the lowest common multiple using that method, then instead we would work out the power which is the greatest of the two, rather than the least of the two. Okay, write down the equation of a straight line with gradient minus 3 which passes through the point 0, 5. Okay, that's the y-intercept. So I could just go straight away and write y is equal to the gradient x plus the y-intercept. By shading the grid, the region defined by all three inequalities. Okay, x is less than 6 means I draw a vertical line at 6. And I'm interested in all the thing which is less than 6, so that's to the left of it. So in fact, what I'm going to do is I'm going to strike out all of the stuff to the right. I'm not going to use that stuff. Y is greater than 2, so I draw a horizontal line at go through y2. And it's greater than 2, so I want all the stuff above it, so I'm going to strike out all the stuff below it. I'm not going to use that area. And then finally, y is greater than x, or less than, sorry, x plus 1. So x plus 1 has a y-intercept of plus 1, and it has a gradient of 1. So for every 1 you go along, I go up 1. So it's going to look like this. And I'm going to draw a straight line connecting them up. And it says here I want y less than or equal to x plus 1. So that means I want everything below the line, so I'm going to strike out everything above the line. And doing it this way, it means you're left nicely with the region in the middle. So you label that R, and then you can highlight that if you wish. Lovely. Okay, next question. We've got scientists investigating the weight of tigers. And we have the number of tigers, and we have the mean weight of the tigers. And it says the mean weight of all 50 tigers is this amount. So with these questions, you just have to find the total weight. Okay, so the total weight is going to be the number of tigers multiplied by the average. So I will do 50 multiplied by 218. And that gives me 10,090. Sorry, 10,900. And then what I'm going to do is I'm going to find the total of the Siberians. So that would be, there's 22 of them, and the average weight is 260. So that's going to give me 5,720. Okay, so that means we can work out what the total Bengals are, because it will be the total amount of weight of all the tigers minus the ones which are Siberian. So we can do 10,900 minus 5,720, and that gives me 5,180. And it asks us for the mean. Always check to see exactly what they're asking you for. And the mean is obviously the total weight divided by the number of tigers, of which there are 28. So we divide that by 28 and we get 185. Well, they are a lot slimmer than the Siberian ones. 185, perfect. Okay, I've got an isosceles triangle here, which means there's going to be a line of symmetry down the centre, which means that makes it a right angled triangle. And if it's a right angled triangle, it means I can use Pythagoras. So I've got 17.5 here and 14 here, because it's half of the base. So this side here, which is, let's call h, will be 17.5 squared minus 14 squared, square rooted. Using Pythagoras' theorem, I'm taking the hypotenuse, subtracting one of the short sides, and that's going to give me the other short side. Okay, great. So I go to my calculator and I write square root of 17.5 squared minus 14 squared. And that gives me 10.5 exactly. So therefore the area of the triangle is a half times base times height, which is a half times 28 times 10.5. So I do 0.5 times 28 times 10.5 and I get 147 exactly. And that's good because it doesn't ask me to round to three significant figures, so I feel like that is a very good answer. Okay, question 10. Jonty, great name, has a storage container the shape of a cuboid, and Jonty is going to paint the outside of the storage container apart from the base, which is shaded. He needs enough paint to cover the top and all four sides. Each tin of paint covers an area of 15 meters squared. He said the cost of each tin of paint recently increased by 10%. After the increase, it was this amount. So let's find out how much it was before. So if we call before x, then x was multiplied by 1.10. That's a 10% increase. And that equaled the new price. So let's find how much the old price was by dividing by 1.1. So 26.95 divided by 1.1 is equal to 24.5. So that's how much the paint used to cost. Jonty says, before the increase, I could have bought enough paint for less than £200. Show that he is correct. Okay, well, let's figure out how much he needs to cover. He needs to do these two kind of squares. They're not actual squares. And each of those are 3 times 2.5, and there are 2 of them. He also needs to do this face, and there's also the same on the back as well, and that's 12 by 3. So 3 times 12, and there are 2 of those. And then he also needs to do the lid. And the lid will be 2.5 times 12, and there's only one of those. 2.5 times 12. Okay, so let's add up all of these to get the total surface area. So 3 times 2.5 times 2 is 15. And 3 times 12 times 2 is 72. And 2.5 times 12 is 30. So add them all up, 30 plus 72 plus 15. So that is a total of 117 meters squared. Okay, so how many tins is he going to need? Well, if I do 117 divided by 15, then that gives me 7.8, which means he's going to need 8 tins. And 8 tins is going to cost him 8 multiplied by 24.5. So 8 times by 24.5 is 196. So we can say that Jonty is correct, as 196 is less than 200. Perfect. Okay, we are drawing a graph, and when we're drawing a graph we should use our calculator to plot the points. We go to menu, we go down to table, and we type in the function, which is just 6 over x. We don't need a second function, so we press equals to pass through it. It starts at 0.5 and it ends at 6. And the gap actually changes, but we will do a gap of 0.5 just to make sure that we have all of them. We press equals, and 0.5 is 12. And the next one is 2, which is 3. And then the next one down is 3, which is 2. We know that already. 4 is 1.5. And 5 is 1.2. Great. And now we can plot. So we plot 0.5, which is here. We plot that at 12. And then we do 1 at 6, which is here. Just being really careful about how they space out the numbers. 2 is 3. 3 is 2. 4 is 1.5. 5 is 1.2, which is here. And then 6 is 1. Great, and then we connect it up in a nice smooth curve, and it asks us just to do those numbers, so we don't need to extend it at all. So we just draw a nice smooth curve, trying to go through all the points. That looks good to me. Okay, next question, expand this. So let's just forget the n is there, and let's just expand these brackets. So n times 3n is 3n squared. N times 5 is 5n. That's minus 12n, and that's minus 20. And then we can simplify inside the bracket. 3n squared minus 7n minus 20. Multiply through by n gives me 3n cubed minus 7n squared minus 20n. Okay, algebraic, some fractions here. We need to find a common denominator, and the lowest common denominator between all these things is 4x, which means I need to times this one top and bottom by 4, this one top and bottom by 2, and this one top and bottom by x. And what does that give us? It gives me 12, and it gives me 2x plus 4, and it gives me 1x. And everything down the bottom will be the same denominator, it will all be 4x. So adding these up, I'm going to get on top 3x, so we've got a 2x and a 1x, and I'm going to get a 16. That's over 4x, and I don't think that can be simplified because there is no common factors there. So we're good. Question 13 is quite tricky, very tricky question. First off, we will substitute in. So a minus b is going to be root 8 plus 4, and then I'm taking away root 8 minus 4. Okay, and then a plus b is going to be root 8 plus 4 plus root 8 minus 4. Okay, let's evaluate each bracket. So I've got a root 8 minus a root 8, so they cancel. I've got 4 minus minus 4, which makes 8. So that bracket is just 8. This one, I've got root 8 and another root 8, so that's 2 root 8. And I've got a 4 and a minus 4, they cancel. So it's just 8 multiplied by 2 root 8. Now I can rewrite this as 8 multiplied, because this 2 is the same as the square root of 4. And I'm going to need the square root of 4 in here, because essentially this is y times by the square root of 4 times the square root of y. So I'm going to need a square root of 4, and that is the 2 right there, so that's helpful. So I can write this now as 2 as the square root of 4 times the square root of 8. And that's perfect, because that's 8 multiplied by the square root of 4 times by 8. So y in this case is 8. Question 14, it tells us that we have a diameter, and it tells us that BAC, so that would be the angle which I find by tracing BA to C, is 55. Great. And it says work out the angle ADB, so that's ADB, so it's this angle in here. And it says give regions for each stage of your working. Okay, well, first off, this is a semicircle because this is a diameter, which means the triangle inside a semicircle is 90 degrees. So I would say that ABC is equal to 90 degrees, and that is due because angles in a semicircle add to 90. Angle in a semicircle is 90. That's all you need to write for that. That is enough. And then I can work out that this one here must be 35. And that's BCA is equal to 35. And for this one, we could just show the calculation. 180 minus 90 minus 55 is equal to 35. And that's angles in a triangle add up to 180. And then the next one is the circle theorem that the two angles which come from the same segment, so there to there and there to there, that they are the same. So I would finish by saying that ADB is equal to 35, and I would say that angles from the same segment are equal. Perfect. Okay, it says using algebra prove that any three consecutive whole numbers. Okay, so three consecutive whole numbers. I'm going to choose n minus 1, n, and n plus 1. You could do n plus 1 and n plus 2, but it's easier working with ones. So whenever I see three consecutive numbers, I always use n minus 1, n, and n plus 1. The sum of the square of the smallest number, okay, so that's this one. And let's work that out. When I square that, I'm going to get an n squared. I'm going to get a minus n and another minus n, so minus 2n. And I'm going to get a minus 1 times a minus 1 is plus 1. And the square of the largest number, which is this one. And when I square that, I'm going to get n squared. I'm going to get an n and another n, so plus 2n. And I'm going to get 1 times 1 is 1. Is always 2 more than twice the square of the middle number. Okay, so let's do that. It's ask us for the sum of these two things we've worked out. So I'm going to find the sum by adding them together. And that's going to give me 2n squared. The n's are going to cancel out, and a 1 plus 1 is plus 2. Okay, so this is what I've got so far. And it's always 2 more than twice the square of the middle number. Okay, and now let's take the middle number and let's square it, and then let's times it by 2, and then we can compare it with what we had before, and we can see there's a 2 difference there. So we can say that 2n squared plus 2 minus 2n squared is equal to 2, which proves that it is always 2 more than twice the middle number. Okay, question 16, we have the first term is 1 and the difference is 4, and it's asking us to work out all of the terms from the 41st to the 100th. So we're going to do sum of 100 minus sum of 40. And the reason for that is that 1 to 100 gives us all of these, and 1 to 40 gives us all of these. So if I do the top one minus the bottom one, then I'm left with 41 up to 100, which is what I need. So the sum to 100 using the formula is 100 over 2, 2 times the first term, which is 1, plus n minus 1, so 99 times by the difference. So let's work that out. We use our calculator to do that. 100 over 2 is 50, multiplied by 2 plus 99 times 4, which is 19900. And sum to 40 is going to be 40 over 2, 2 times 1 plus 39 times 4. And let's do that on our calculator. So that'll be 20 multiplied by, in brackets, 2 plus 39 times 4. And that is 3160. So our final answer is going to be 19900 minus 3160, which is, oh sorry, not 3160, 3160. Yes, good. 16740. Perfect. Okay, we have similar shapes here, and what I will do is I will work out what the scale factor is, the linear scale factor, by taking the larger one and dividing it by the smaller one. So I have a linear scale factor of 1.5. It says the difference between the volume of base A and the volume of base B is 1197. So let's call X the volume of base A. And if I want to convert between volumes, I'll need to work out the volume scale factor, which is k cubed, which is 1.5 cubed, which is 27 over 8. Or as a decimal, 3.375. So if the volume of A is X, then the volume of B, I'll need to multiply by the scale factor k cubed, and that will give me 3.375x. Now the difference between the two volumes will be one of them minus the other, or the larger one minus the smaller one. So this will give me, if I have 3.375x minus 1x, that's 2.375x. And we also know that that is equal to 1197, because we're told that's what the difference is. So to find x, I will just need to take 1197 and divide it by 2.375, which gives me 504. Okay, simultaneous equations of the quadratic nature is how you work out where two lines intersect. So essentially all I need to do is just solve simultaneously. So I'm going to take the linear expression and I'm going to rearrange it so that we have x or y as the subject. Here, rearranging it so x is the subject is the easiest. So minusing 1 is going to give me 2y minus 1. Next, I'm going to write out the quadratic expression, and I'm just going to replace every x with a 2y minus 1. So I get 3y squared plus 7y plus 16 is equal to x squared, which is 2y minus 1 squared, minus 2y minus 1. Okay, next I'm going to expand these brackets, and I'll just do this over here on the side, just to make sure I don't make any mistakes. This gives me 4y squared minus 2y plus 1. So that's 4y squared minus 4y plus 1. Okay, great. So we've got 4y squared minus 4y plus 1. And then I'm going to multiply out this, being very careful to apply the negative to both terms. So I get minus 2y and I get plus 1. Okay, great. I look to see which side has the highest y squared, which is the right side. So I'm going to move everything over to the right side. 4y squared minus 3y squared is just 1y squared. 1y squared, I've got minus 6y over here, and then minus another 7y gives me minus 13y. And then I've got 16 there, I've got a 1 and a 1 makes 2 take away 16 is minus 14. That's good because this factorises nice and neatly, like so, which tells me that y is equal to 14 and y is equal to minus 1. And we know from here the x coordinate is 2 times the y minus 1, so double the y to make 28, minus 1 is 27. Double the y to make minus 2, minus 1 is minus 3. So those are the coordinates. Doesn't specify which is which, so we are good. Just write them in here because it asks you for the coordinates, so 27, 14, and minus 3, minus 1. Chord theorem states that if I have a intersection point, in this case t, then if I multiply to the edge, if I measure to the edge and then multiply it to the other edge, which in this case is 12, that will equal me multiplying this way, which is 3, by this way, which we'll call x. Okay, great. So we have 48 is equal to 3x. So x is equal to 48 divided by 3, which is 16. Okay, so if x is 16, then we now know the diameter of the circle, which is from one side to the other, is 16 plus 3. So the diameter is 16 plus 3, which is 19, which means the radius is 19 over 2. Or 9.5. Either's fine. Here we've got to complete the square. So first off, I like to write it in descending powers, like this. I like to take the two terms that have x's in and factorise out whatever the x squared coefficient is. So I'm going to take out a minus 3. And that leaves me with x squared, and if I divide 12 by minus 3, I get minus 4. And I'll keep the constant term outside. Next, I'll look at the b term here, which is minus 4, and I will half that to get minus 2. So I'll then write x minus 2 all squared, take away minus 2 all squared. Okay, we can simplify this because minus 2 all squared is 4, and we're taking it away, so we write minus 4. And then we can reintroduce the minus 3 by multiplying it to both of these two terms. So I get minus 3 lots of x minus 2 squared. Minus 3 times minus 4 is plus 12. And also we've got this plus 7. Okay, so finally, if I want to write it in the form they ask me to, then the constant term is first, which is going to be 12 plus 7, which is 19. And then b is what we multiply by the bracket, which is minus 3, and then x minus 2 all squared. Okay, it says the curve C with the equation, which is the same as the one we've just completed, the maximum point A is... So the point A is the maximum point of C. Okay, so find basically the maximum. Well, if we look at this, the biggest number that can come out of a squared bracket is 0, because you can't have a negative come out of a square bracket. So how do I make that bracket 0? Well, the x-coordinate which makes that 0 is 2. So 2 is where the maximum point is going to occur. And when that is 0, then my y value is just going to be 19 minus 0, so it's 19. And that's the maximum point. Okay, this question, we've got lots of information here. We're saying this is a square, that's an equilateral triangle, this is a prism, the EF is twice AE, and we've got M as a midpoint. So what I'm going to do, we've got no length, so I'm going to assign a length. And I'm going to assign this length here 1, and this length here 1, which makes this 2, which makes EF twice AE, so that's 4. So then I'm just working with whole numbers, which just makes it a lot easier than using halves. Okay, and what are we looking for? We are looking for the angle, tan of the angle is what we're looking for, and the angle y is MAJ. So from there to there, from there to there, and then directly down, just like that. Okay, so the first thing I noticed is I can work out this side here, the light blue one, because that's just part of the base. So if I were to draw a light blue triangle like this, and then I would draw it over here, it would look something like this. And the side AG, so this will be A, G and M, and AG is 4, and M is, or GM is 1. So what I'm looking for is going to be 1 squared plus 4 squared square rooted. So that's the square root of 17. Okay, great. So I know one side of my triangle already. So that's root 17. So I'm going to need to find another side of my triangle, and ideally I want to find the opposite, because this is y and we've been asked to work out tan of y, so really we're going to need the adjacent and the opposite. So I need the height of this shape. So if I just draw a quick sketch. Okay, so now I need to focus on the right angle triangle, the equilateral triangle at the top. If I draw this line down there, then this would be 1, that side. This would be a 60-degree angle. And ideally I want to find the height of the equilateral triangle. So I can use tan here, and this tells me that tan of 60 is equal to the opposite over the adjacent, which is just equal to the opposite, which is the height. And tan of 60, we could do that on our calculator if you don't know your exact values, but that is the square root of 3. So if that's equal to the square root of 3, then the overall height, which I'll draw in purple, is going to be 2 for the square and the square root of 3 for the height of the triangle. So it's going to be 2 plus the square root of 3. Okay, so now we're good to go. We can work out what tan of y is. Tan of y is the opposite, which is 2 plus the square root of 3, over the adjacent, which is the square root of 17. And that's great, because that's what we're trying to work out, tan y. But it wants it in a form where we have a rationalized denominator. So I'm going to have to multiply this top and bottom by the square root of 17 to rationalize this denominator. So on the bottom, that's going to give me the square root of 17 times by itself is just 17. And on the top, I'm going to get 2 root 17 plus the square root of 17 times the square root of 3 is the square root of 51. And even that's not completely done, because it actually asked me for root q plus root p, or root p plus root q. So this is a bit of a problem, but that's okay, because 2 can be written as the square root of 4. So just grabbing some more space. The square root of 4 times the square root of 17 plus the square root of 51 all over 17. And we have two surds together like this, we can just multiply the two numbers. So the square root of 68 plus the square root of 51 all over 17 is our final answer. Question 22 on perpendicular lines. So we're told we have a triangle, so it'd be a good idea just to quickly sketch a triangle. And the right angle is ABC, so that means essentially it's a B here, so I'll put A here and C here. And we are told the gradient of AC, so the gradient of AC is minus 6 over 7. Okay, so what is the gradient? The gradient, we can use the formula m is equal to y2 minus y1 over x2 minus x1. So in this case, the gradient, which is minus 6 over 7, is the change in the y's between a and c. So that would be q minus 10, and then the x's will be 8 minus p. Okay, great. So we've got our first equation. What I'll do is I will pick up the denominators and multiply them to the other sides. Pick up this denominator, multiply it to that side. So cross multiplying is going to give me minus 6 lots of 8 minus p is equal to 7 lots of q minus 10. I'm then going to expand the brackets. I'm going to get minus 48 plus 6p is equal to 7q minus 70. Okay, great. And then what I might do is just rearrange slightly. So add 70 to that side is going to give me 22. And take the 6p away, so I'll get 7q minus 6p. And now that's set up nicely for a simultaneous equation. But I'm going to need another equation. And I'm going to use the fact that these two lines are perpendicular, so their gradients will multiply to make minus 1. Okay, so let's first start with the gradient of a to b. So again, what I'll need to do is look at a and b and do the change in the y's. So that will be, we'll take this away from that. So 10 minus minus 5 over the x's, so that will be p minus minus 1. Okay, and that, when we multiply it by the other gradient, which will be b to c, so I will do q minus minus 5 over 8 minus minus 1. And when we multiply those two together, we should get minus 1 because they should be the negative reciprocal of one another because they're perpendicular. Okay, great. Let's simplify a little bit. So we've got 15 over p plus 1 multiplied by q plus 5 over 9 is equal to minus 1. Let's multiply it across. So 15 times q plus 5 is going to be 15q plus 75. And on the bottom, we're going to get 9 times p plus 1, so 9 times p, and 9 times 1. Okay, then I'm going to take the denominator and multiply it to the other side. So I get 15q plus 75 is equal to, times it by minus 1 is just going to make everything negative. So minus 9p minus 9. And then I am just going to move it all, I'm going to move the 9p over to this side, so I get 15q plus 9p, and I'm going to move the 75 to that side, so take away 75 from minus 9 is minus 84. And great, I've got my second equation for q and p, which means I can now solve them simultaneously. So I'm going to take this second solution, and I've noticed it's all divisible by 3, so I'm going to divide it all by 3. Dividing by 3 is minus 28. And I can spot here that I've got a 6p here and a 3p there, so I'm going to double this one here to line up the p's. Minus 56. Okay, great. So these are my two equations now that I can solve for. I'm going to write one of them. I'm going to move this one underneath to line them up. So 7q minus 6p is equal to 22. I can draw a line, and I can add the two equations to cancel out the p's. That's going to give me 17q is equal to, adding those two together is minus 34. So dividing through, q is equal to minus 2. Okay, brilliant. That is confirmed. That is legit. And now we can substitute back in to find P. Let's go for, let's just do, which one should we do? Lots of options here. Let's sub into this one. I think that's probably the easiest one to sub into. Okay, so Q is minus 2, 5Q is therefore minus 10, plus 3P, and that equals minus 28. Add 10 to both sides, gives me minus 18. Divide through by 3 gives me minus 6. And we are done. Okay, here we go. Tricky question, really tricky one. And if you can master this one, then you've got functions absolutely sorted. Right, it starts off, you've got this horrible looking function, and then it says find the value of p for which the inverse function of p is equal to k. Now, you're not going to want to try and find the inverse function of this. Instead, you're going to use this really neat trick. And that is that if f of x gives you a value of y, then it means the inverse function will go backwards and you swap x's for y's. So here we have the inverse function of p is equal to k, which means that the original function, if I were to sub in k, it would give me p. Okay, so let's solve this instead. That's going to be much easier. So sub in k. Subbing in k for x is going to give me k squared plus k squared, all square rooted, over k. And we're told that's equal to p, which is great because p is what I'm trying to find anyway. This is going to give me the square root of 2k squared over k. And a square root like this, when I have two things multiplied together, I can split it up to write the square root of root 2 multiplied by the square root of k squared. And that's going to be helpful because we have the square root of 2 and the square root of k squared is just k. And our k's will cancel, so we have that p is root 2. Okay, second part of the question says that g is defined as g of x is equal to x squared, and it says given that g of f of a is equal to k, find the expression of a in terms of k. So I need to put a into f and then f into g. So putting a into f will give me the square root of a squared plus k squared over a. And then if I put that into g, well, that just means to square essentially your input. So I will square all of that, and that is equal to k. Okay, right, when I square a fraction, I can square the numerator separately and the denominator separately. So squaring the numerator is going to remove that square root sign, and squaring the denominator is going to give me a squared. Now I want an expression for a, so I'm going to have to collect all the a's on one side and then factorise. So first off, I will multiply both sides by a squared to get this, and then all the terms that have an a in it I'll put on the left side, and all the terms that no, actually I'll put all the a squares onto the right side. That'll be easier because it means I just have to move that one a squared over. So I get k squared is equal to a squared k minus a squared, and then I will factorise an a squared, which gives me k minus 1, and then I will divide both sides by that factor of k minus 1. And then the last step is to square root. So it will be the square root of k squared over k minus 1. Okay, final question. We have a particle moving along a straight line Displacement is given as x. Normally it's given as s, but it's the same thing. It's in terms of t, which is time, and the direction of motion of p reverses when p is at the point A on the line. So when something reverses, at that particular instant, the velocity must equal 0, because it must stop and then turn back on itself. The acceleration of p at the instant when p is at A is given as little a meters per second. Find the value of little a. Well, they're really making this unnecessarily complicated. So essentially, to find the velocity, we just differentiate the displacement. 3 comes down, times by the 4 to get 12t squared. And minus 27t differentiates to minus 27. And 8 is a constant, so that differentiates to 0. Like I said, we need to investigate the time when the velocity equals 0. So I'm going to set that equal to 0. And I'm going to add on the 27 to the other side, divide through by 3, divide through by 4, and square root, which is fine to do so because the negative, we can't have negative time anyway, so the time is 3/2. And then it's asked me to find the acceleration. So the acceleration is the derivative of the velocity. So I differentiate this 12t squared minus 27, and that's going to give me 24t, and 27 differentiates to 0. And I need to investigate the time when it changes direction, which we've already established is at t is equal to 3/2. So it's 24 times by 3/2. Which is 36. And we're done.